Hello, welcome to your latest Maths Wizard video. Today we're going to be looking at similar shapes, which is one of the many shape topics on the GCSE Maths syllabus. So the main skills today are these two here. So it's about explaining why shapes are similar to each other and then using the fact that shapes are similar to calculate missing lengths on two sets of shapes. So if shapes are mathematically similar to each other, what this means is they're identical in terms of the shape, but not inside. So we've got these two squares on the picture here. So you can see this square has a side length of 4 centimeters. This one has a side length. So this one here has 4 centimeters. This one has a side length of 2 centimeters. Because we've got two squares, squares have 4 identical sides to each other. So any pair of squares is always going to be similar to each other. Okay, so all it means is that this one is twice as big. So this has been enlarged by a scale factor of 2, which basically means how many times bigger it is compared to the smaller square. So two key facts to remember here. Now, two circles are always similar. So any two circles are always similar because you have one continuous length, and any two squares are always similar, and that is because you've got 4 equal sides. Okay, so there are two facts to remember, but it does get a bit more complicated with other shapes. So two rectangles could be similar, but will probably not be. So a key thing to remember is this little sentence here. So for two shapes to be similar, there needs to be a direct relationship between the sizes of the two shapes on every single side. So you've got two pairs of sides that are the same length on a rectangle. There's got to be the same scale factor on every single side. And I'm going to do a few examples on the next slide to show you what I mean. So let's say, I don't know, this is 5 centimeters, this is 2 centimeters. Now, if this was 10 centimeters and this was 4 centimeters, these two shapes would be similar. So your scale factor here would be 2, okay, because both sides are 2 times bigger. We do 5 times 2 to get 10, 2 times 2 to get 4. Now, that would work with other lengths as well. Let's say it was, I don't know, let's say this was 15 instead. That would have to be 6. But then you'd have a scale factor of 3 because every side is 3 times bigger. But let's say this was still 4. These two shapes would not be similar. Okay, so because there's not the same scale factor on each side. So your top side is 3 times bigger, but your left and right hand side are only twice as big. So these two shapes would not be similar. Okay, so remember when you've got shapes that aren't regular shapes, the shapes where there are different side lengths, it's not always the case that these shapes are similar. So bear that in mind. Okay, right. So we're going to move on now then to calculate some missing lengths on similar shapes. So let's have a look at some examples. So these two triangles are similar here. All I would like you to do is work out the side of DF. So this side at the bottom between points D and point F. So if you pause your video and have a go. Okay, so let's take a look at this then. Now, what you need to do with these sorts of questions is have a look at the sides you're already given. So if we look at this side AB, which is 4, and look at this side DE, which is 16, these are equivalent sides on this triangle. So it's about then working out the connection between 4 and 16. And we can do this using a division. If you do 16 divided by 4, you get 4. So what that means is your scale factor is 4. So this larger triangle is 4 times bigger than your smaller triangle. So all you've got to do then is take the equivalent side on the small triangle, which is 5, multiply it by 4, and you'll get 20 centimeters. What they could also ask you to do as well, they might say, well, what's BC? And you would then do 17 divided by 4 if you were to go the other way, which would give you 4.25 if you wanted to figure out that one. So sometimes this involves multiplication, sometimes it involves division. So anything where you're scaling up or scaling down, remember it's going to be about multiplying and dividing. Don't try and do this with addition or subtraction. Okay, let's go to another example then. Okay, so on this one we've got these two trapeziums. I would just like you to work out for this first one side x on this first one. Okay, let's have a look at this then. So we've got 1.5 and 4.5 there. So if we do 4.5 divided by 1.5, that gives us 3. So our scale factor on this set of trapeziums is 3. So we've got to go and do 2.2 times 3 now to work out that x, and that will give us 6.6 centimeters for that top one there. Okay, let's use this same trapezium then again for another question. So this time I'd like you to work out side length of y. Okay, so here then we've got 4.5 divided by 1.5, which is 3. So all we've then got to do is 9.6 divided by 3, because we're going from the larger trapezium to the smaller trapezium, and that will give us 3.2 centimeters for that one. So sometimes, remember, if you're going from the larger side to the smaller side, there might be a division involved on those questions. Okay, let's do one more final example then. So I've got quite a bit. This is from a past AQA paper. I've got quite a bit for you to work out here. So I want you to do angle X, side H, and side W. And you're being told that these two shapes are similar and that B is an enlargement of A, but in your scale factor here is 1.5. So you're actually being given the scale factor on this one, okay? Okay, so let's have a look then at this. So we've got the 54 degrees. Let's do the easy one first. Now, one key thing to remember, this is sometimes that people think people do incorrectly, is that when you enlarge a shape, the angles will still be the same size. So that X will still be 54 degrees. It does not get 1.5 times bigger. It's only the side lengths that get 1.5 times bigger. Right, now we're going to, if we do H, well, we've got this 5 centimeters here, so we can multiply that by 1.5, and that will give us the length of H, which is going to be 7.5 centimeters. And then with 9, we're going back down to the smaller shape for the W. So 9 divided by 1.5 is going to give us 6 centimeters for that one. And that is it for this question. And that is it for this video. So thank you very much for listening. Make sure you hit subscribe and you'll see loads more videos appearing over the next few months. Okay, thanks very much. Bye bye.